This is MSJ Chem. In this video, I'll be looking at the technique of back titration. A back titration or indirect titration has two stages. In the first stage, one reactant of unknown concentration is reacted with an excess reactant of known concentration. In the second stage, the amount of excess reactant is determined by a direct titration. Back titrations are often used when one reactant is insoluble in water, for example, salts such as calcium carbonate. A common experiment using a back titration is to determine the percentage calcium carbonate in an eggshell. So next we look at an example of how to do this. A student carried out an experiment to determine the percentage calcium carbonate in an eggshell. A 0.4 gram sample of eggshell was crushed up and reacted with 25 centimeters cubed of 0.5 mole per decimeter cubed hydrochloric acid. Here we can see the reaction that takes place between calcium carbonate and hydrochloric acid. The calcium carbonate in the eggshell reacts with hydrochloric acid to produce the salt calcium chloride, water, and carbon dioxide gas. Next, the excess acid was titrated with 0.5 mole per decimeter cubed sodium hydroxide. The average titer was 12.10 centimeters cubed. And here we have the reaction between sodium hydroxide and hydrochloric acid. The products of the reaction are sodium chloride and water. The first step is to determine the amount in moles of hydrochloric acid in 25 centimeters cubed of 0.5 mole per decimeter cubed HCl. To do this, we use the equation N equals CV, where N is amount in moles, C is concentration, and V is volume in decimeters cubed. So we have 0.5 times 25 divided by 1000. We divide by 1000 to convert from centimeters cubed to decimeters cubed, which gives us 0.0125 moles. Next, we determine the amount in moles of excess hydrochloric acid. To do this, we calculate the amount in moles of sodium hydroxide that reacted with the excess hydrochloric acid. So that's 0.5 times 12.10 divided by 1000. And this gives us 6.05 times 10 to the negative 3 moles. If we look at the balanced chemical equation between sodium hydroxide and hydrochloric acid, we can see the molar ratio is 1:1. Because of this, the amount in moles of sodium hydroxide is equal to the amount in moles of excess hydrochloric acid. So the amount in moles of excess hydrochloric acid is 6.05 times 10 to the negative 3 moles. Next, we'll determine the amount in moles of hydrochloric acid that reacted with the calcium carbonate in the eggshell. To do this, we subtract the amount in moles of hydrochloric acid that was in excess from the initial amount of hydrochloric acid. So that's 0.0125 minus 6.05 times 10 to the negative 3, which gives us 6.45 times 10 to the negative 3 moles. Next, we'll determine the amount in moles of calcium carbonate in the eggshell. Here we can see the balanced chemical equation between calcium carbonate and hydrochloric acid. As we can see, the molar ratio of calcium carbonate to hydrochloric acid is 1:2. So next, we divide the amount of hydrochloric acid that reacted with the calcium carbonate by 2. This is because of the 1:2 molar ratio of calcium carbonate to hydrochloric acid. So the amount of hydrochloric acid that reacted with the calcium carbonate is 6.45 times 10 to the negative 3, which we then divide by 2, which gives us 3.23 times 10 to the negative 3 moles. The final step is to convert from amount in moles to mass in grams. So we use the equation mass equals amount in moles multiplied by molar mass. When we multiply these two together, we get a mass of calcium carbonate in the eggshell of 0.323 grams. And finally, we can determine the percentage of calcium carbonate in the eggshell. To do this, we divide the mass of calcium carbonate in the eggshell by the total mass of the eggshell and multiply by 100. So that's 0.323 grams divided by 0.4 grams multiplied by 100. which gives us 80.8%. This tells us that the eggshell is approximately 81% calcium carbonate by mass.